Hello, my name is Max, and I'm sick today, so I'm taking off work, which means I get to give this talk I wanted to do in a while about introducing idiomatic modern Gradle. Just a quick background about me. I've worked with Gradle for a number of years and always found it completely mysterious. Everyone I worked with finds it completely mysterious, very confusing. So I set aside a lot of time to learn the heck out of it, and now I'm presenting this to you. That being said, this is really just an introduction, a very short introduction. This is not a long talk, because Gradle is huge and complicated. I really can't go into much more detail, and I think the official documentation is the best way to do that. However, I found it extremely difficult to learn Gradle. It was hard to kind of ignore a lot of the noise and get down to the really crucial information. So this talk is trying to fast track you to that, get you to the good stuff as quickly as possible, and give you a general framework for understanding even just how to Google this stuff, basically. So that's the talk. So, let's go. So first of all, great quote. One of the most irritating things programmers do regularly is feel so good about learning a hard thing that they don't look for ways to make it easy or even oppose things that would do so. I think I found this on Twitter. I think this is a very important quote for this talk, because when I finished learning Gradle, it took me like a whole week, literally 8 hours a day for a whole week. I started developing this talk, and I fell for this trap myself. It was excruciating learning Gradle. I think I got depression in the process. And at the end of it, I wrote this talk that was like, isn't it great that Gradle does it this way? You should do it this way. This is awesome. And I'm like, what? Am I going crazy? Because I think what happened is I just felt so good about being through it that I had just drunk the Kool-Aid by that point, and I was selling it now. But I don't think that's good. As you'll see, I really don't think Gradle does things in the best possible way. And so it's important to remember that and kind of potentially push for change. I don't know, tell the Gradle developers it doesn't need to be this way or something. Don't be satisfied with this tool as is, because at the end of the day, I really do hate Gradle. I'm sorry, I just have to acknowledge that. I am gonna give you some recommendations about how to use it, and we'll get into that, but it's really not a good tool, in my opinion. It is powerful, I'll give it that. It's amazing what you can do with Gradle, but I think it's incredibly over-engineered. If you look at how Gradle is used, 99% of cases where Gradle is used, versus what Gradle is capable of, there's just a vast gulf between them that it really doesn't need to have all that complexity, I think. It could serve 99% of its users and be a much, much simpler tool. But that's how it is. So part of the problem with it as well is it's designed in this very opaque way, where it's hard, even if you have a Gradle build, to understand how that build is working. And that's sort of by design. It tries so hard to abstract away everything that it's really hard to just look at it and be like, okay, what steps are you running here? What are you doing? How's this hooked up? In general, it's a horrible learning experience, partly because of that opacity I talked about, but also because just the documentation is awful. There's, even on ignoring all the outdated documentation on the internet, there's a ton of that. Just looking at the Gradle website, it's incredibly hard just to find a straightforward, up-to-date, not highly Java specific guide about how you're supposed to be using Gradle. It's scattered amongst all these pages with seemingly no organization between them. There's tons of snippets that I swear do not work if you copy paste them into your Gradle build, that are just not sufficiently explained. It's really not great. Very hard to learn. I had a really hard time, at least. But unfortunately, it is better than the alternatives in many situations. In many cases, it's the recommended tool to use. It's very popular for Android app development, for one. So you might just end up having to use it because, I don't know, the team you're on wants to use it or something, whatever. The point is, if you're going to use Gradle, or if you're already using Gradle, at least try to use it the right way. Don't fight it, you know. Use it the way that the designers intend it to be used. Don't stick around with some super old version of Gradle where you just like pray and never touch the build script. You should be at least keeping it up to date, following best practices, trying to get some benefit out of the tool rather than fearing it. So that's what this talk is really about, is using it the right way. So now let's go into the Gradle intro. So Gradle's a build tool. If you've never used Gradle before, maybe that's new to you, but even someone who's just used Gradle a little bit is probably familiar that it has tasks. You define tasks. Tasks are the parts that actually do stuff in the build. Tasks can have dependencies on each other. And then Gradle can resolve the execution order. So it can see all the tasks and make this web of dependencies and figure out like a smart way to run all the tasks to do whatever you're trying to do. And that's what Gradle is. But I would say that view is actually very unhelpful. That's how I thought Gradle worked before I really started digging in and learning it. It's true in some sense, but it's so oversimplified as to be harmful almost to your understanding of Gradle. So if that's how you think Gradle works too, throw out that idea. Try to start from a blank slate. Here's what Gradle really is. It is a tool for designing build tools. And as soon as you accept that, you'll start to understand why it's so complex. Because everything about Gradle is kind of designed for these this meta level, where you're not just building like an app or building a library, you're building a tool to build those things. So it does have this powerful, remember that means over-engineered, dependency resolution system. So that does involve tasks. Tasks can have dependencies. But also you can have Gradle builds themselves. You can have like sub-builds within a Gradle build. Those can have dependencies on each other. A build can have multiple sub-projects within it with their own dependencies. And there's many types of dependencies. It's not like there's just, I depend on that. There's specific ways to depend on things, artifacts, capabilities, components, configurations, variant modules, platforms. All these things are different ways of depending on things, or different types of dependencies, or different mechanisms for resolving dependencies. They all have subtle differences with each other. This is one of the most confusing parts of Gradle. This is why it's one of the reasons why it's so hard to learn, is all these different ways of kind of defining things and the scope of things and the way those scopes relate to each other. It's very non-trivial. It also has a powerful, there's that word powerful again, plugin system that can basically change everything about the tool. It's kind of impressive. It's hard to design something like that, so it is powerful. And the intent of the Gradle designer seems to be that everything you can abstract essentially should be abstracted, which I don't think is a great idea. Personally, I think abstraction can be confusing and it can make your build harder to understand, but that's the intent of Gradle. A lot of its mechanisms work best when you create abstraction in your build process itself. So the overall idea of how you're supposed to use Gradle, this in a nutshell is what modern idiomatic Gradle is about. You're supposed to use Gradle to define to define a custom build tool, essentially. A custom build tool, which is like, this is how I'm building my app or my library or whatever you're building with Gradle. And maybe that build tool is using some existing plugins off the shelf. It probably has to. But you're going to wrap that up in a custom build tool using Gradle. And then all that your actual Gradle build is going to do, your Gradle build script to build your actual code that you care about, all that that's going to do is load your custom build tool and configure it. It's going to like tweak some options and stuff like that. Point it at the data that it needs. That's the goal with modern Gradle. So, I think the most important thing now is to understand how Gradle structures things. That's like the best way to understand how to look up information about Gradle, how to understand other Gradle builds that you see, is just understanding the structure of a Gradle build. So let's look at that. 1 second. I am sick. Okay, so highest level thing is the build, sometimes called a component in the documentation. A Gradle build is defined by the presence of this settings.gradle file. So in the root of your repository, of your code repository, the root directory, you should have a settings.gradle file. This is the top level configuration for your Gradle build. I'm using the .kts extension because I like using Kotlin syntax with Gradle. If you leave off the extension, it's a groovy Gradle file, but that's fine. Either way it works. Settings.gradle defines a build. So you always have a root build, guaranteed, in your project, or you should at least. Then you can have sub-builds within it. This is often why builds are called components, because if your software project can be logically broken down into components that are built separately from each other, you should do that. Again, Gradle wants you to abstract as much as possible. So, for example, if you're doing like a client-server application where the client and server are built separately, those should be separate Gradle builds, or can be built separately. They should be separate. So each of these would have its own subdirectory with its own settings.gradle file, because that's what defines a sub-build. In addition, you should have a plugin build. This is conventionally put in Gradle/plugins. That will have its own settings.gradle file. And this is where you're going to define your whole custom build system that I mentioned earlier. So that's your situation. Usually also, I should say, if you only have like a single component, or like a project that doesn't logically break down into multiple components, probably still want to organize it as just like a component for your actual, code that you're trying to build, and then another component for the plugins, just to keep it clean. Technically, you can do everything in the root build and just have Gradle plugins for your build system, but that's a little messy. I've tried to do that before. It gets a little weird. So I should say you should always have at least 3 Gradle builds. The root build, which you have to have, a component build, 1 or more component builds, and then the plugins build. Next level in, we have the project. So a Gradle project is inside a Gradle build, and a project is defined by the presence of this build.gradle file. In the docs, these are often called sub-projects, sometimes called modules. And so just as we always have a root build, we always have a root project, but here you don't necessarily need that file. So if you want, you can define a build.gradle file at the root level, but the root project sort of implicitly exists, even if you don't define that file. You can also define sub-projects within your component builds. So again, as the name kind of hints, these are sometimes called modules because, say, for example, your component is built out of, maybe it has like multiple frameworks inside it that are sort of logically distinct in some way. Those naturally map to sub-projects. And so let's say component 1 here is built out of 2 separate frameworks. Maybe we have 2 sub-projects for those. But maybe component 2 is simpler, it doesn't need that much structure. You can just use the root project in a component build, that's fine. You don't have to have sub-projects. So in this case, component 1 would have 2 subdirectories. Each of those subdirectories would have a build.gradle file. Component 2 would just have a build.gradle file directly in its directory. And I guess I didn't include it in the diagram, but also technically component 1 also has a root project. You always have a root project around implicitly. I'm just not showing the box there. It's always there, even if you don't define the file for it. So you can structure things like maybe component 1 does some stuff in the root project, but then it has these sub-projects like for libraries that it's defining. There's various structures you can use. The plugins build also has sub-projects. And in most of the ways that matter, these sub-projects are identical to any other sub-project. So there isn't that much that's special about them. They still are defined by a build.gradle file being in a directory. They have that build.gradle file has all the same options as any other build.gradle file. It's totally normal. The one thing that's special about them, and it's why I gave them a different color, is you'll define the type of that build as Kotlin-DSL. So in that build.gradle file, you'll say, this is the type of Gradle build that I'm doing in here. And that is like an internal type recognized by Gradle so that it sees like, oh, this is a Gradle plugin that you're building. And that's important because it means that, you need that so that Gradle understands like, okay, I can build this plugin and then incorporate it into other parts of the build. So you need a special type to identify them. Then inside those plugin projects, we're going to be defining mainly two things, tasks and extensions. Sorry, my face is covering up the extensions, but there are extensions in the bottom right corner for plugin B as well. Usually you'd have both for all plugins. So tasks, they do things. So you can define multiple task types here. So these are types of ways of doing things. And so this is a little bit abstract because you're more defining like, okay, what kinds of inputs do I need for this task? What kinds of outputs does this task produce? You're not necessarily, you're not intended to specify, specific details like where are those inputs coming from? Or what are those outputs going to? Or are those being written to a file or anything? Tasks are supposed to be pretty abstract because they're supposed to be flexible and reconfigurable. So you're really defining the types of things that your plugin will do a little bit more abstractly. The goal being that if you define the types of things that it does and abstract things like what sort of input does it need, what output does it produce, then Gradle can be more intelligent about how it hooks that up and making sure that your task runs only when it absolutely needs to. Extensions, you'll define, again, types of extensions. You'll define like what sort of configuration can be done on my custom plugin that I'm developing. So like what options can be tweaked on it? What sort of input does my plugin need in order to work correctly? And the goal is that the extension will define basically your own custom domain-specific language for configuring your plugin. This is how all Gradle plugins work, pretty much. If you've ever used a Gradle plugin before, they're all configured in a domain-specific language. So you load the plugin, and that adds like a keyword where you can say, for example, if you load the Kotlin plugin, now you can say Kotlin, open curly brace, and inside those braces you can do Kotlin-specific things. That's what you define in your extension. Now, the other thing you need here, potentially that exists in projects before we finish the plugin talk, just a brief aside, is you can also define tasks directly in other projects. But here, you're not going to be defining types of tasks. You really shouldn't be doing that. What tasks you should be defining in your projects are what are conventionally called lifecycle tasks, which are basically the tasks that are just kind of like tying things together. So that would be things like run all of the tests in all of my sub-projects, or, build all of my code and deploy it to some server. Like those kinds of things that are just grouping together other tasks that are defined elsewhere. That's the kind of tasks that you might define in other projects. And that really should be it. This is one of the big things where sort of idiomatic modern Gradle diverges from the way Gradle is usually used. Usually what you'll see in someone's root project is just everything. They'll define like 30 different tasks and all this custom thing, and every task for like doing whatever weird operation your app needs to do, and like running code generation or whatever. It'll just do everything in the root project. Modern idiomatic Gradle says, don't do that. Instead, define all these custom types of tasks in your plugins. And then, the other tasks that you define in these other projects, these purple projects in this diagram, should be very simple tasks that are just like grouping things together if you want to have like basically like a convenience task to run multiple other tasks. That's all that should be in there. So then going back to the plugin now, the last thing that should be in there is these convention scripts. And these look a little bit weird because they look exactly like a build.gradle script. They have the exact same structure. What's special about them is that they don't actually define a sub-project like a build.gradle file does. Instead, because they're in a plugin, Gradle compiles them to produce the plugin itself. And so what these convention scripts are going to do, conventionally, as indicated by the arrows, is they're going to say, okay, we've got all these custom types of tasks. Let's maybe define some concrete names for accessing those tasks. And let's also define some concrete extensions and the name that that extension is going to use when you access it. Like when you type Kotlin to access the Kotlin plugin extension, that's what's defined here in this convention script. And it's also going to hook everything together. So it can do things like, okay, when they configure it with the extension, I'm going to pass those inputs to these tasks, and I'm going to set up those tasks to do the right thing. So the convention is the convention script is the glue that ties together the custom plugin. And in a way, you can think of it as like the convention script, because it works just like a build.gradle script. The idea is that when your plugin is included, it's almost as if that the contents of this convention script are just kind of like copy-pasted directly into your build.gradle file. So this is the main way in which you abstract away the complexity of your Gradle builds, is by putting as much of that complexity as you can in these convention scripts. So now that these are defined, we can include them, as I just said. So in this example here, we have like this project X and the root project of component 2 are both including plugin A, and the other one is including plugin B. And the idea of the structure here is that you should have like one custom plugin for each type of build that you're doing. So in this example, maybe our project involves both building some Kotlin code and building some Java code. And we have conventions for how we do Kotlin stuff, like certain libraries that we're using, certain ways of testing things. And we have conventions for how we're doing Java stuff. And these are, maybe in our project, there's like a hard line between them. We never mix the two. So then plugin A could be like our Kotlin convention, and plugin B could be our Java convention. And so then by including these plugins here, we're really defining the types of these builds. We're saying, okay, project X and component 2 are Kotlin builds because they're including our Kotlin plugin, and project Y is a Java build because it's including our Java plugin. This is a common way of looking at plugins in Gradle in general, not just custom plugins. All plugins are really defining the type of build. And so this is another way that Gradle is sort of misused according to modern standards by the Gradle developers, which is like often what you'll see in people's builds in the wild is this root project will just include like 10 different plugins. So that means it's 10 types of build all mixed together, which is kind of complicated. And so the idea here is like, okay, if those 10 plugins are working together to, build your Kotlin code in a certain way, then just pull those into a custom plugin that says, this is how we're building Kotlin, and inside there it's pulling in those 10 plugins and configuring them and all that kind of stuff. And then in your actual project file, you can then just say, instead of including those 10 different things, like especially here where we're reusing it in 2 different components, then you can say, okay, pull in the way we're building Kotlin to both of these, and then you have like a single source of truth for customizing it. That's the idea behind that. And then the last component here that you'll see commonly used are source sets. And these are just ways of grouping together source code. It's a slight abstraction over things like a directory, basically. And source sets are a little bit confusing because on their own, they basically do nothing. They have no functionality. It's just a way to group together files. They exist as a thing for plugins to use. So, for example, if you pull in a Java plugin, it'll have certain ways that it works with your Java source sets. For example, you'll commonly see things grouped into like a source directory and a test directory. And there's like implicit relationships about how those relate to each other. And source sets will often hook into the plugin's dependency resolution, where the plugin can define separate ways to have dependencies for different source sets. So again, kind of confusing here, because it's like, if you look up documentation for source sets, often what you'll actually find is documentation for how a particular Gradle plugin is using source sets. But technically, another plugin could use them totally differently. There's just like common conventions, I guess, where they tend to be used a certain way, especially between things like Java and Kotlin that have a similar JVM foundation. So another thing that makes it really hard to learn Gradle is because you're like, okay, I want to figure out how my plugin in particular is using source sets, and you'll find tons of Google results about how other plugins are using source sets. Like, for example, if you're using Kotlin multi-platform, it does a bunch of interesting stuff with source sets. Like, it defines all these new kinds of source sets so that you can have like, okay, if I'm compiling my Kotlin to JavaScript, I want code specifically related to that platform. It has a custom source set for that. The Java plugin has no idea what a JavaScript source set is. Only the Kotlin multi-platform plugin understands that, just as an example. And so that's the structure. So I think what I want to do here now is we're actually going to leave the presentation, and I'm going to go over to web browser, and we're going to look at this pretty interesting GitHub repo called idiomatic Gradle. And this is actually by Gradle developers. These are Gradle developers here. And it's an example of a project that's kind of using the structure I just said as much as possible. Again, they love abstraction, so this is like abstracting to the max. And so the reason why we're looking at this is just to kind of show you as an example, like if you're looking at a Gradle build, like say just to learn Gradle, and you want to understand by looking at examples, how do you even approach looking at that? So that's what we're going to go through here. Like I found this and I was like, this looks like a good example, but I really haven't gone through it before, so I actually have very little idea what I'm looking through. So I think this is a somewhat realistic example, because like I'm gonna be poking around just trying to figure out what's going on here. So let's dive in. So first thing, like we're in a project, we believe Gradle is involved because we see several Gradle related files. We've got all these things with Gradle in the name. What's the first thing that we look at? I'll pause if you want to test yourself here on your Gradle knowledge. First thing, root build, right? We talked about this, how top level thing is the root build that owns everything else. That's defined by settings.gradle. So here we are, settings.gradle.kts. This is going to define the overall build for the entire repository. And so what's going on here? We can see root project.name equals idiomatic Gradle. So we know what that is, root project. That's this little purple box here. So kind of interesting that the root build configures the root project. I'm not exactly sure why they did it this way. I think it might have to do with what I said about how the root project is sort of like, one, not necessarily needed, not necessarily needed for most projects, and also that it sort of implicitly always exists. So maybe that's just like, if you don't want to have that file around at all, you configure it in the root build. And then we've got this dependency resolution management block. And well, comments here are helping them. The actual product split into multiple components. So include build, and then include build aggregation. And so you can see that they have multiple builds that this is split into. API data server. So this is some kind of like client server application, I guess. I have no idea what this build produces. Build responsible for assembling the final delivery or producing reports. Does not predict direction code. Okay, so it seems like they've created a build just for sort of build management tasks. So there's a lot of flexibility in how you define things in Gradle. It isn't really that there's one project configuration. It's pretty interesting, actually, if you read the issues for this repository. There's all these debates where people are like, well, shouldn't it be organized in this way? Isn't this the better thing? And the Gradle developers are all arguing about it. So it really isn't like a hard rule that you can follow. So anyway, yeah, so that's what's in here. So really we'd have to go into one of these builds to see more detail. But before I do that, let's just check if we have a build.gradle to actually configure stuff in the root project. And we do, with lifecycle tasks. So here we go. So these are the examples of things that they consider to be lifecycle. So tasks named group, do last, and component task. So there's a lot of interesting mechanisms built into Gradle. It's another thing that's like really hard with Gradle is like its API surface is kind of huge and not easy to discover. So like there are ways to like hook into tasks to modify them. So in this case, I'm guessing they have a bunch of tasks of this type task report, and they wanted to have like a single thing that's sort of like adding this help info to all of them. So that's what this is hooking into, to say like, okay, after you run that task, add this little help information, which is interesting. But let's see. Okay, yeah. Perfect task here is just like checking all. So this is going to run all verification tasks for everything. And you can see, yeah, this is like probably a good way to define a lifecycle task is generally all they do, they have a description and then they just depend on things, which is the way to say, run this task, or rather run those other tasks when I run this task, right, is just to depend on them. So in this case, more fancy Gradle magic, we're saying like, okay, look at all of our included builds, find the ones with a certain name, and then get their task with this specific name and depend on it. So this check all task depends on all the sub-builds check all tasks. And aggregation uses a different package or a different pattern, so then for some reason we want to include this one as well. So you can kind of do custom stuff in all these. So these all seem pretty similar. They're all just doing depends on. So that's that. So where do we go next? Gonna have to be one of these sub things, but I really want to see where they're defining custom plugins. And it's interesting because I don't see them actually including plugins here. So I'm wondering if they have a different plugin structure. But just to double check, let's look in Gradle. They do have plugins here. Okay. So they have a bunch of plugins that they've defined. So I'm curious what is pulling that in. I wonder, can I search for Gradle plugins? Ah, okay. So whenever you define plugins, custom plugins, they're always going to be included in this plugin management block. And so you can see here, they're just like kind of an interesting structure, I guess. Their sub-builds are including the plugins. So they have to go up a couple directory to find the plugins to include them in plugin management. So this is where their plugins are. So they put them in the conventional location, but interestingly, they also have a bunch of other custom Gradle stuff in here. So this I'm less familiar with, but I think the idea here is like you can define, in addition to just like custom plugins, you're also sort of like defining custom components in general for your Gradle build. And we'll look at some of those. Again, I'm not very familiar. But anyway, looking here, so we can see this is a Java project. And so they have a Java convention plugin, which is defining like, this is how we've decided to build our Java code. And so, before we do that, always start at settings.gradle. It'll tell you the overall structure, though there's probably nothing fancy. Tells you where they're getting plugins from. Include build platform. Independency resolution management. Okay. and then version catalogs. Yeah, so I think this, I've read a little bit about this before. This is the idea of like having a central source of truth for like what dependencies do we use and what versions are they. If you want that to be like super consistent throughout your project, I think that's what this stuff is about. Not required by any means. I haven't actually used it yet, but I can see why it might be appealing. And so all we're doing in here is we're saying, okay, these are all of our custom plugins that we're defining. So yeah, now let's look at the Java one. So look at the build, which configures it. There's Kotlin-DSL, so that's telling us this is a custom Gradle plugin, or rather it's telling Gradle as well. Gradle looks at this type, right? Build.Gradle defines the project, right? It defines this purple box, or I guess this green box, that's what we're in right now. And we need to tell Gradle that the type of this project is Kotlin-DSL, so it knows it's a plugin. And then here we have dependencies. So these are dependencies that will be compiled into the plugin itself, right? So what this is saying is that whenever we compile our Java code, we're going to include this plugin, and automatically we're going to have Guava available, and I guess this is I have no idea what this plugin is. So something from the Gradle community. Sure. So these are essentially like, this goes back to what I was saying before, like instead of your script including like 10 different plugins, that's kind of what we're doing here. This is, again, one of the confusing things about developing a Gradle plugin. We want it to be that when I include the Java convention plugin, I get all of these other plugins for free. That's what we're doing here. But because we're in a plugin itself, these are just dependencies, right? We're just pulling these dependencies here to say these are part of the plugin that you get. And you'll see in a second where that comes in. So here is our script. You can tell because it's named the same way. We're in, well, no. Yeah. Well, so it's Java. I'm actually not exactly sure. I think each of these, so I don't know why this naming convention is just Gradle magic. So you always need the .gradle.kts, and then you always need the package at the beginning. And then I believe this identifier at the end is more freeform. So this initial part is how this is going to be included. We can, actually, let's just double check that. If we look for com example Java, we should see, there it is. So we can see that the IG data right, so the IG data is a build. Data has a build.gradle file, so that means data is a sub-project, and we can see that the data sub-project is pulling in the Java convention plugin because it is looking for that initial part of the name, the part that comes before gradle.kts. So that's just some Gradle magic about how those names are looked up. So anyway, we can go in here. Well, actually, I did want to check real quick. Let's see one of these, like Jacoco. Is that used? Com example. Jacoco. It's a code coverage thing. Package server. Okay, yeah. So each of these is defining a separate plugin script. So that's interesting. I'm not exactly sure why they've done that. I guess they're similar enough. So basically, like, they've defined two separate plugins, but they put them both in the same plugin project. Well, actually, like, so we can see this plugin project, Java Convention, essentially defines 4 separate plugins, which is kind of interesting. I guess they're all Java centric, so they group them together. Again, just flexibility, it's up to you. So, so here, remember, this is what I was saying, where like this script is essentially, when you include this plugin, it's kind of like copy pasted into your Gradle build script. So here, this plugins block, again, we're not defining a Gradle build right here. We're defining a plugin itself. And this plugins block is what is going to be copy pasted in when you include this. So by defining this here, we're keeping all this noise of like, okay, I need to do Java, which means I need these like 7 different plugins just to do some Java stuff. Now that's much simpler, and we can instead just say, get our Java plugin, and you get all this for free. And then we can it also pulls in dependencies. This is the platform thing, I think, getting us specific versions. Compare details of Java. Need to clear convention to remove. Header output directory. I have no idea what this is doing, but apparently something is wrong with their Java compile task where they don't want a header output directory. Where maybe not wrong, they want to tweak it. So this is an example of the kind of things where it's like, usually you would see this, again, everyone in the wild, they would just define all this stuff in the root project. They would say, okay, I'm compiling Java, I'm going to pull in my 7 Java plugins, and then I don't want a header output directory, so then I'm going to configure this. But now you can abstract all that away, and you can say, literally every single time we're building something with Java, we don't want headers. So let's just define that in our convention plugin so that there's less of a chance of you like forgetting to configure that, essentially. And this, okay, so this configurations, this goes back to Gradle just having way too many types of dependencies. Configurations are very confusing. You can see, I love this variable name, isCanBe, wonderful. So configurations have 2 types, resolvable and consumable configurations. So here we're defining this as a consumable configuration, and it's, roughly speaking, a dependency group is what you're defining. So it's like grouping together things which can be depended on in a very abstract way. Not a very useful definition. So in this case, essentially, I think what it's doing, so you can set kind of like metadata on that configuration, which is what this is doing. And then it's also including the outgoing artifacts from the source directories. So, I mean, the comment here says, with other projects for aggregated Javadoc and Jacoco reports. So I guess the idea here is like, because everything's grouped into these sub-projects that are like each individually compiling Java, if you want a overall Java report to say like, okay, how are all of my sub-builds using Java, then you need a way to kind of iterate over those sub-builds and have a standard way to ask each of them, like, okay, give me like your Java build information. And so that's what this configuration does. Like, it essentially just gives a name to this group of information and says it's consumable. So if we look for where this is used, that's weird. I would assume something would refer to this. I don't know. Gradle is confusing. I would assume something would actually pull that in, unless something is just like iterating over all configurations, maybe. Yeah, I don't know. I'm not sure how that's actually getting gathered. Maybe like the Jacoco one would look at it. Okay, maybe this is how... Well, no, this is another consumable configuration with the coverage data. Is this being referred to? Nope. I'm still not a Gradle expert. This stuff is confusing. And this is one of the things I hate about Gradle is like all these levels of abstraction. You get some nice things, but also just becomes incredibly confusing to figure out how this stuff is getting linked together. Anyway, so that's that. So then if we go back to, I wanted to look at like where one of these things was used because I don't want to get too down in the weeds here. Project, I think IG data we saw used Java. So now we're going into a sub build, right? IG data, you can tell it's a sub build because it has a settings.gradle file. So we're including the settings plugin, which is interesting. And then we're applying a plugin, this repositories plugin. I'm also not familiar. This is, again, like levels of abstraction I'm not even familiar with. So this is interesting. I haven't seen this before. They're applying a plugin at the build level, and I'm guessing that this is just defining which repositories they're using. Let's just go back and check out their settings plugin here. Non-traditional build source, but Gradle plugins as a normal included build. Interesting. Yeah. I'm not wild about it, but I get it. So normally, yeah, so this is kind of like the crazy thing about Gradle. It's like very powerful in this way where it's like very consistent, right? So I talked about how before, like when you define a Gradle plugin, when you define one of these convention plugins, it gets like essentially copy pasted into your file. You can do the same thing with a settings.gradle file. So that's what they're doing here. They're defining a settings.gradle.kts. So this is their plugin for configuring settings. So all of their Gradle builds, rather than having, basically the common things you'll see are these two things. So usually in a settings file, I guess I didn't talk about this specifically, in all of your real components that are like building your real code that aren't building Gradle shit, you'll always see these things. You'll see plugin management to say, get my custom plugins, and you'll see dependency resolution management to say, where am I allowed to get dependencies from? And so you'll almost always see Maven Central there. Then in this case, they're also pulling in this platform thing and this versions thing. I believe that's, again, for the consistent versioning. And so I'm assuming what happened is when they were building this repository, they saw every single one of our settings.gradle files is repeating this. And since Gradle loves to abstract everything as much as possible, they're like, every problem can be solved with a custom Gradle plugin. So they defined a custom Gradle plugin just for defining these settings. And so that way, in their actual settings block, like for data, so this is defining the IG data sub-build. Now they can just say, okay, get our settings plugin and load it. That's what these are doing. And that gets you all of that we just looked at. And so then the only other thing they need to say here is like, what sub-project do we have in this sub-build? And it's the data one. And again, this would just be lifecycle, so they're just pulling in lifecycle. They did the same thing here. I guess they probably have a standard set of lifecycle tasks that are doing things like run all tests, gather all code coverage or whatever. And so they similarly defined a plugin for that. You can it's plugins all the way down. Same thing. And then, so now in the sub-project, so that's actually kind of interesting. Like I wouldn't have necessarily thought to do this. I would say like once I'm in the sub-build, like in this example, maybe just use the root project. That's good enough because you only have, if you only have one thing, just use the root project. But they decided not to do that. For some reason, they decided it's more idiomatic to explicitly like use the root project for lifecycle and explicitly make a sub-project just for this data thing. So that's that. And yeah. So then going in here, this is their build. So it's a Java build. We saw that. So here's an example, maybe not the best example, but like, look how simple this script is. So this is like their normal. Again, this is like, here's our actual code. This is why we're using Gradle in the first place is because we're just trying to compile some freaking Java code. But they've abstracted it so much that this is their actual Gradle build file that's doing all the real work is just blah. So that's what they want you to do, and maybe that's appealing to you, to have it so simple. I think it's a little confusing as well in a way, right? Because it's like, how are you compiling Java? And you really have to understand Gradle to understand like where all of this has been hidden away from you. But that's the goal, and look what they've accomplished. Incredible. So then you can go into the source, and here's like, yeah, they just have like this trivial project structure. So I'm not going to go through this more. This is probably pretty boring. So that's just me talking through viewing someone's incredibly abstracted idiomatic Gradle build. So I hope that was useful for you, useful to you. That was the whole talk. Well, I will leave you with some links. Resume worst. Okay, here we go. So here's some links. I know you can't click these links, but I'll include the links in the description. So first of all, the structuring large projects docs basically goes over everything I just said, but in more detail. I think the name kind of sucks because it says large projects, but in my opinion, if you're doing anything beyond trivial Gradle projects, like a toy project, anything beyond that, these docs are probably useful to you. Like you should be at least using some of this structure. Maybe don't use like as much of it as possible, but use some of it. The Understanding Gradle video series is fantastic. That's where I learned a lot of this stuff as well. It goes through all this with like concrete examples. And then the project structure repo that we just looked at. And I'll also have a follow-up video after this one going through building a project with a kind of weird custom plugin, just so you can see some of that stuff in action and a bunch of interesting techniques as well. So that's that. And thank you.